Okay, 2.7 is the next section, so we're going to be solving equations in one variable, and I tried to throw in a lot of rational equations since that's what we're talking about. So we're going to solve these. We'll look at extraneous solutions again, and we'll hopefully do some application problems as well. All right, so to review an extraneous solution, in case you don't remember, these are solutions that pop out from the algebra, they don't actually work. So we have these a lot whenever we're dealing with square roots and whenever we're dealing with rational equations, because we know that we can't have, negatives underneath square roots, and we can't have zeros in the bottoms of fractions. So these are the places we really need to look out for. So here's an example then. Clearing fractions is definitely the way to go with these. So how to clear fractions is you multiply through by the least common denominator. Since these are all rational and they're all 1 in the bottom, I want to multiply through by x minus 3. It makes the problem so much easier. If you do that, you get x times x minus 3. These cancel, so that'd be plus 1 equals x minus 3. It instantly turned our rational equation into a very simple quadratic. Okay, so I'll distribute x squared minus 3x plus 1 equals x minus 3. We'll subtract x from both sides and add 3. And you get x squared minus 4x plus 4 equals 0. And that is something we can solve. We will try to factor that, x minus 2 times x minus 2, which I can just make that x minus 2 squared. And then you can see the zeros, or the solution is x equals 2 with a multiplicity of 2. But that is the solution to my rational equation. Now let's check that to make sure that it works. When I plug in 2, do that in a different color here. When I plug in 2, I get 1 over negative 1 equals 1, and that's true. 2 plus, this is really negative 1, and that does equal 1. So it does check. All right, let's try another one. This one, we're going to clear fractions by multiplying through by x. If you do that, you get x squared plus 2, these x's cancel, equals 3x. And once again, we have a quadratic. Subtract 3x from both sides. And try to factor that if you can. X minus 2, x minus 1. And that gives you x equals 2 and 1. Those are your two solutions. Now, double check these to make sure they both work and not one of them is extraneous. So the first one, when you plug it back in, you get 2 plus 1 equals 3. That's true, so that one checks. Now try 1. When you plug in 1, you get 1 plus 2 equals 3, and that checks as well. So they're both solutions to this rational equation. All right, let's try an extraneous one. So let's try another one. This time, a little bit harder. I need to find the common denominator in order to clear fractions. So I'm going to try to factor this bottom into x minus 3, x minus 1. And so there's the common denominator right there. I'm going to multiply through by that to everything. Okay, so multiply through by x minus 3 times x minus 1. And in this time, the x minus 3's cancel, and I get x minus 1. In this one, the x minus 1's cancel, and I get 2x times x minus 3. And then in this one, the whole bottom cancels, and I just get 2. So we took a really complicated rational equation, and we simplified it into a quadratic with one step. This is 2x squared minus 6x. And then we can turn this into 2x squared minus 5x. Minus 1, if we subtract the 2 over, that'd be minus 3. And I'm not sure if this factors actually, so quadratic formula is easy enough to just really quickly do. So 5 plus or minus the square root of 25 minus 4 times a times c all over 2a. Double negatives go positive. 8 times 3 is 24. So this would be 49, so it did factor, it looks like. Because you get 5 plus or minus 7 over 4, which is 5 plus 7 is 12 over 4, which is 3, and minus 7 will be negative 3/4. I'm sorry, negative 2/4, which is negative 1/2. All right, so when we check these, 3 doesn't work right away because if you stick in 3, you get an undefined right there. So that doesn't work right away. My guess is then, so this is extraneous. Negative 1/2 then probably does work, but we should check it. So when you go to check this, you have 1 over 1/2 minus 3 would be negative 2.5 or negative 5/2. I'll just do negative 2.5. Plus 2 times negative 1/2, so negative 1. And then, I'm sorry, that's it is negative 1/2. So this would be negative 3.5. Sorry about that. Plus negative 1/2 and then negative 1.5. So double negatives equal positive here. I'm just going to deal with fractions. Why not? 3/5 is 7/2. So this is really negative 2/7 plus. This is really 3/2, 1.5. So plus 2/3, and that should equal what's on the right side, which is 2 over negative 1/2 squared minus 4 times negative 1/2 plus 3. Might as well. I know this is good fraction practice. So multiply top and bottom by 7 in this case. Multiply top and bottom by 3 in this case. So it's negative 6 over 21 plus 14 over 21, which gives you negative 8 over 21. That should be what we get on the right. Let's check that out. This is positive 1/4 plus 2 plus 3. Double negatives go positive here. And let's see, negative 8 over 21 equals 1/4, so I need to get a common denominator, multiply top and bottom by 4, top and bottom by 4. And that gives us 2 over 9 plus, so there's 21 over 4. Instead of dividing by a fraction, we'll multiply by 4 over 21. And that gives us the 8 over 21, but it seems to be positive. I don't know if I made a mistake with the negative sign somewhere. Probably did. I'm not sure. Let me double check that. Yeah, I did. This was positive, right? 14 plus negative 6, so that's positive. So it does check. You get positive 8 over 21 equals 8 over 21. So you can check this without a calculator. I know it's good fraction practice, but it is difficult. But it turns out that is a solution right there. Let's just try one example problem then. This says find the dimensions of a rectangle with minimum perimeter. So first of all, if it's a rectangle, I usually draw a picture because that helps us get us going. We have length times width. Now we know the area is 300 square meters. So we know the perimeter is 2L plus 2W, and we want to minimize that. We know the area is length times width, which equals 300. So we've got these two equations with two variables. In order to graph this and make a function, we need to eliminate a variable and have the perimeter rely on only one of these variables, like length or width. It doesn't matter. I'll divide both sides by width, so I get length equals 300 over width, and then I'll substitute that in for length right there. So it's 2 times 300 over W plus 2W. That's equal to the perimeter. And now the perimeter is a function of W, since it's only got one variable in it. So we could graph this function and we could minimize it real quick. So now if you graph this, I used X instead of W. Well, you should be able to zoom out. You should be able to find this point right here, which minimizes the perimeter. And you might want to zoom in on that point, depending on what WebWork wants. But this problem would be 17.32 for X, which was our width. So W equals 17.32. That minimized the perimeter. But I need to find length. In order to find length, I have to plug it back into either one of these equations. So I'd actually just plug it into this one right there, because 300 divided by that width gives us the length. That's what we found here. So 300 divided by this gives us 17.3 about. So about the same, 17.32. Turns out a square then is what would minimize the perimeter if we had a rectangle that was a square. There's an application problem of how to deal with rational equations and how they can be applied to solve a real world problem. But we'll try some more of these in the homework, and hopefully this will help.